crazy thing called congruency. Remember what that meant? The same. What was the same? Yeah, same size, same shape, same measurement. Perfect. So when we talked about this thing called congruency, that meant it was the same size and shape, same measure, same measurement, whether it was a segment length, whether it was or an angle measurement. It could have been any of those. And what we do here in geometry is we talk about things in terms of congruency, because congruency is a fancier thing than just equality. Because of the idea, like you were just saying, with the same sizes and shapes. And that's kind of glad you said it that way, because we start looking at shapes. Figure, because it's geometry. I know. Weird. So what we like to do, or what I like to do with this, is to show you guys how it works, kind of right off the bat with just letters, without looking at shapes, without looking at stuff like that. Because if we talk about the idea of having figures that are congruent, if two things are congruent, or more things are congruent, let me write this out. Congruent figures, they have all corresponding parts congruent. Now, if I'm talking about in terms of a triangle, how many parts are in a triangle? Yeah. How many parts do triangles have? I heard the fart of the alarm going off too. Yes. How many parts do triangles have?
30. Yeah. Like sides.
There's 6 parts, right? There's 3 angles and 3 sides.
Oh.
Yeah, that's. I guess I should preface that I'm hoping you know what I was talking about. So there goes that. So yeah. So when we talk about parts, that means sides and angles. Okay. So if I have a triangle, that means there has to be 6 parts that have to be congruent. 3 sides have to correspond to 3 sides. 3 angles correspond to 3 angles. If it's a quadrilateral, what is that? 8. 4 angles, 4 sides, okay, and so on and so on and so on. So obviously, we're going to spend the bulk of this chapter talking about triangles. Don't get me wrong, we will see some quadrilateral stuff, we'll see some weird things here, but a lot of that goes to the algebra of just following lettering around. So that's not going to be so bad. But what I want to look at is something like this. And I want to write out, what are the parts? What's that symbol in front of the ABC? Triangle, very good. That tells you that you're working with a triangle. If it didn't have the triangle symbol, it would just say you're working with ABC. Well, if I just have ABC, what could it be? It's not going to be a line. It could be an angle, or it could be a plane, yeah. But if we know it's not a plane, we know it's not an angle, it's triangle. Okay. So that means when you label triangles, what do you have to have in front of it? Triangle. Okay. So how many angles are in a triangle? 3. Now, if I have a triangle, if you can just kind of visualize this with 3 angles and 3 sides. Remember how we labeled our angles? Remember how we said that we have to label angles with a singular letter or with 3 letters? No? Okay. Well, like we unspace out, but the honesty's good. If I just look at this for a quick example. angle E up there. How many different angles is angle E? Turn it off, please. How many different angles are could angle E? Three. Two small ones and the big one. Okay. So the reason why we use 3 letters, we use 3 letters with something like this because we'd have to have AED, AEC, DEC. They're all 3 of those angles are different. Whereas if you just had it's only angle E. Does that make sense? So you can use 1 letter if there's just 1 vertex at that spot. The other ones had multiple vertices. Okay. So we just start thinking about in terms of how lettering matches. A is the first letter in triangle ABC. What letter does that have to match up with in the other triangle? X. And it's going to be quite literally this simple. That the first letter has to match the first letter. The second letter has to match the second. And guess what? The third matches the fourth. Okay. What that stands for then is that angle A will be congruent to angle X, B is congruent to Y, and C will be congruent to Z. That's how this stuff works. So in a diagram right away, how do you mark a diagram for angle measurements being the same? Remember that? Exactly, with the little tick marks. Remember how we make the little arcs? Angle A has to match up with what? X. B and then lastly C. That congruency statement, if you will, that congruency statement that says that ABC has to match up to XYZ, that means that those letters match. Okay? Those vertices will match. Those angles match. But triangles aren't just made up of angles, they're also made up of sides. And how many letters do you use to make sides? 2 of them. If you look at it, your side lengths are going to be segments that have endpoints at the vertices, yeah. AB, first 2 letters, matches to XY, first 2 letters. Also notice if you have your angles marked up, 1 tick mark to 2 tick marks is AB. 1 tick mark to 2 tick marks on the other one is XY. They automatically will match. The segments between the correct corresponding tick marks will also be congruent. That's kind of like a kicker on these things. That's how this stuff all involves. Between B and C, it's the same thing of Y and Z, A and C, X and Z. It all works itself out. It's a congruency statement. What can you say and from it, right? Hey guys, those of you with all your earbuds in and stuff and they're really listening to everything else, take them out. I guarantee you guys are going to screw this up. All right, please. There's a time and a place, and right now is not the time and the place. What this is going to allow us to be able to do is to look at a diagram and tell whether or not something is going to be congruent, or use the algebra from a picture to see how things match up to solve for X, solve for Y, that kind of stuff. It really isn't going to be all that scary bad, to be honest with you. All right? Show. Oops. How would you write out a congruency statement for that?
No. Triangle ABC. Congruent to F.
Okay.
I mean triangle.
You guys are right. Now, what you're saying, you went right away to triangle ABC. Because mentally, you guys always think of the alphabet. You try to just start with that right away. And that's fine. There's nothing wrong with that. But that just means you have to follow the right tick mark pattern on the other one. 1, 2, 3. 1, 2, 3. So it has to be, yeah. See what I was getting at that? Now, if I said, what happens if you said triangle? Turn it off. Power it off. You can do it.
Wait, is that called the system?
Yes, sir. If I say triangle CAB, what would the letters have to be? DFE? See what I'm getting at here? It doesn't matter how you start it, just as long as the letters match up. Your lettering just has to match, because if I say CAB, 3, 1, 2, 3, 1, 2, I have to match it up. That's what I'm getting at here, guys. There's going to be multiple ways to write out statements. You just have to pick the correct direction to go. Because that's really what you're doing. You're telling what direction to walk around a triangle. You're telling how it matches itself up. Because even here, it says DF has to match up with CA. Well, DF, 2 tick marks. CA, 2 tick marks. It's fine. Because your congruency statement that you wrote matches the diagram at hand. Okay? Which means algebra. Fix this picture. So in this diagram, it tells you have this congruency statement. DFG is congruent to SPQR. It says that DFG is going to be congruent to SPQR. Well, when you have that, and as you're starting to draw this stuff through, start to think about, okay, what parts have to match with what? Now, a lot of times, depending upon what information you're trying to solve for, what information you're trying to look for, if it's asking you to do find x and y, if I start looking to see where x and y are to begin with, I can use the congruency statement to make it easier on myself. For example, yes, sir. Well, let me walk through this first while I send it through. I appreciate you being able to pick it out real quick, because that's good. Because if you look at the diagram, see how the diagrams start exactly lined up perfectly? They do that a lot. They will rotate it, they'll invert it, they'll shift it, they'll do a whole bunch of what are called transformations to things to move things around on you to make it look like it's harder than it really is. So if I start by looking at trying to solve for x and y, well, if I'm looking at x is at QR. QR are the last 2 letters. What are the last 2 letters of the other figure that it has to match up with? FG. Could it go with DE? No, it can't. It can't match up. It can only match up with the 1 letters of F and G because of this congruency statement. QR, FG, they have to be equal because that's what the statement says. So what the congruency statement will tell you is it basically tells you without telling you how to set something equal. You'll run, Dick Geron. He was coach of the Bears a few years back. I'm on that show. It's not my show, but I'm on that show. His old coach's corner type of radio show. Not my show, but I'm on that show. It's called the Dick Geron Show. Thanks for the awkward laugh there. So algebraically, all I have to do is this. 2x minus 4 has to equal what? Well,
Easy money.
here x is 8. Okay. The next part is where you have your angle. You have angle Q. Angle Q says 6y plus x. Well, it's a good thing I just solved for x. That means that angle Q is going to be 6y plus 8. But Q is which letter in the statement? Yeah, it's the third. It has to match with F. Good. What does F equal in the other one? 68. See how you're using that to match up? So you get 6y plus 8 is 68, and you could probably figure that out in your head. I hope. Try it again. Maybe 5 more times. Yeah. So I said 5 more times. Yeah. My humor is lost on you guys. You need to. He said 2, and I said 5 more times. Sorry to disappoint you. Hey guys, this is the kind of stuff that we're looking at. It's the algebra you're going to find. It's real quick. You don't have to go through the whole process. You can. You know that everything matches out. D matches to S. G would have to match with R. And so on and so forth. You can match them all together because sometimes it'll say, hey, knucklehead, solve for everything. Well, you can solve for every angle in there, except for you won't be able to figure out your side lengths because you don't, the other 2 extra side lengths because you don't know how to do that yet. But remember how many degrees are inside of a 4-sided figure? 360. Good. So could you figure out what angle E is? Yeah, you just subtract all the other ones from 360. So that's little things that I don't think it shows up, but it could. Are these triangles congruent? And if so, how? And then write out a congruency statement if they are. Remember, what we have to have here to show that triangles are congruent is that, or figures are congruent, is that all of the corresponding parts have to be equal. And after a lot of counting, we hopefully have recognized that you need to have 3 angles and 3 sides. It means you have to have how many pieces equal to each other, congruent to each other. All right, let's see what we can figure out. Are they congruent?
Yeah.
How? All the side lengths are the same, okay? And how many angles together are the same? 2. How do we get the third one equal? You're right, you're a step ahead of me because what happens here is that if these 2 angles are 50 and 60, that means these have to be 50 and 60, which means your leftover has to be the same. What you're using is what's called the third angle theorem, which we're going to talk about here in about 2 minutes. But what's the other reason why these 2 angles are congruent to each other? Vertical. They're very good. They're vertical. Remember we talked about vertical angles before? Oh yeah, that thing. These have to be congruent because they're vertical angles. So these are congruent. Triangle ABC has to be congruent to triangle. All right. Now, do you guys remember this thing?
What thing? Oh, that's a square.
Remember that?
Right.
We haven't used it in a while, have we?
We don't care.
Yes, you do. You will. Remember that progression sheet?
Directions.
Remember that little sheet of squares, that little blue sheet of squares?
Oh.
Yeah, buddy.
We gotta fill that out.
Yes, sir. This is where this thing's going to become your best friend, ladies and gentlemen.
This is the proof thing?
Yes, sir. We're getting there. Now, as we get into this more and more, I only have a couple of these left. If you, like, as in 3. So if you have lost yours or whatnot, I only have 3. I will make some more next week.
I do not.
But one of the things I want to get at with this, you environmental hater. Is it, what is it? Is that what they are from the? Yeah. Yeah, I was going to say, yeah, I knew it was. My kids love that. It's a good one. My kids love that one too. And we actually get yelled at when the kids are throwing out their trash. They're like, well, it doesn't have a recycle piece on it, so can I recycle this? You know, they're not sure. The reason why I wanted to bring this back to you guys real quick about this whole progression sheet is because as we get into talking about congruencies and talking about triangles being congruent, we're going to have to look at a bunch of different tricks. And some of the tricks that we look at is how in the world can we show that certain parts are congruent to each other inside of triangles. One of the tricks that we always look for, that we try to look for, is we always say to look for vertical angles.
Are we writing that down on one of our squares?
Good idea. And the reason why I want you to do this is because I want to put inside that little diagram there, that one of the squares, an example of what it looks like. So draw a little, I don't know, almost like a bow tie-ish looking thing. And we know that those two have to be equal. And I'm going to call it angle 1 and 2. Just for sake of argument, just to be able to write it out quickly. And if you remember, after we did that, in some of the other squares, because I think we only have on there right now midpoint, angle bisector, perpendicular, and linear pair, I think. Yeah. So really all we have on there, but if you look, we also put examples of how you would write that in terms of a 2-column proof, a statement, what you're saying, your reason, why you said it. Remember how we did that in an example on all those?
Yeah.
Well, let me write down what it would look like if you happen to have vertical angles. Statement, what you're doing, reason, why you're doing it. One of the things you can do from diagrams is you can infer information. For example, we can infer linear pairs. We can go to two angles form a line, they're a linear pair. We can infer vertical angles. We can infer vertical if you've got the, not vertical, excuse me, perpendicular if it's got that little rectangle box in the side. That means that it's a 90-degree angle. So you can infer that information from it. So here I can say that angles 1 is congruent to angle 2, and my reason, vertical angles, are congruent. And that's all I would have to write. It's going to come in really, really handy when we get into some stuff with proofs. Because eventually we're going to be having stuff that looks like this, where you'll have it'll say that C is the midpoint of BD. C is the midpoint of AE. Prove triangle ABC is congruent to triangle EDC. And we're going to go from something like this given information to show that they actually are congruent. And that's something every one of you guys can do right now, because on your progression sheet, it tells you. What do you do if you have a midpoint? What does it say you have to do?
Wait, when you have a midpoint?
Yeah, what does it say to state? You would say segment equals segment. Well, if C is the midpoint of BD, what are the two segments that are equal? BC, CD, right? Reason, definition, midpoint.
Oh, yeah.
C is the midpoint of AC. Not AC, I'm sorry, AE. AC, CE. Do you see anything else that's congruent?
Well, yeah.
I don't know that. What can I infer from my diagram, though? Look for vertical angles. That's the kind of stuff we'll be able to do. You have information that has a definition, that has something to tell you what to do, something you can infer. All of a sudden, you have two triangles circulated. That's the idea of what we're going to. That's how proofs work. You're going to be given some information. You write out your definitions. What can you infer? And you have something proved. Okay. If there's not a lot of leeway off of that, it's just a do this, do this, do this, do this, and that's why we keep these handy. So that way, if you ever get lost and you go, I don't know what to do. Well, what do you have? I have a midpoint. Okay, what's it tell you to do? Do it. Okay. So that's where we're getting to. Let's see.
Do we have all the numbers?
Nah, not really. Just like we were saying a second ago, if we have triangle ABC and triangle XYZ, that's 60, that's 50, that's 50, and that's 60. How many degrees are inside of a triangle? 180. Okay. What does angle X have to equal? 70. Because 50 and 60 add them together, you get how much? 110. So these two add together to be 110, which makes this one 70. What do these two add up to equal? Which makes this one. So just like Chase was saying a second ago, is that when you have two angles that are congruent to each other between two triangles, the 50, the 50, the 60, the 60, the third angle will always be equal between the two. Always, 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 always. Because math. Because they always have to pull that math. Because they always have it on 180. Okay. That's like you were just saying, you brought it up. That's something that's called the third angle theorem. It's one of the things that you'll see probably more often with algebra than you will with a proof. To be honest with you, I don't believe we ever come across it in a proof, but if we do, we'll make sure we write it up on a progression sheet, but I don't think we will. It's one of those that you'll have a diagram and you just work backwards out of and you can find a specific angle. Basically, it works out where you're going to be given something like a triangle CAB is congruent to triangle YZX, and it'll say that angle C is 50, angle Z, oops, is 60. What is angle B? That's the kind of thing you're looking at. How you're going to play it off of both triangles. That's kind of what it works with to start with. It's super easy to use, and you probably would have been able to figure all of that out without too much of a hassle, because a lot of times it would come along with a congruency statement. Okay. If I just have the congruency statement, do I have enough information to figure out what X and Y are? I'm sorry, it's boring. There's no way to make any of this fun. I'm trying. Yeah, there is. And again, it comes with the idea that you don't need to draw out the whole thing. Because if you look at what information you have, you're trying to solve for X. X is at the segment of JF. JF is the last and the first letter. What matches up the last and the first letter in the other one? The AE, right? Do I have the value of AE? 10. So all I would do is 3x plus 4 is 10. Because these letters match, I just write it out. I don't have to draw the whole picture. The congruency statement will help you to kind of shortcut yourself through a lot of stuff. What's X? 2. We okay with that? Subtract 4, divide by 3. And then again, the other one with the angle. You have the fourth letter, which means it has to be the fourth letter. Add 9, and it was how much, Joe? Again, notice the algebra is not difficult. This is really straightforward stuff. It's just using the lettering to get you there. Sir.
So,
It's a mix. It'll have the algebra part, then it'll also have like a congruency statement between a figure, and it's going to ask you, hey, what's congruent to segment CD? If I say what segment's congruent to CD, what would you say? What's congruent to CD? If I just ask you, CD is congruent to what? CD goes 3 to 4, so that means it has to be 3 to 4, which is HI. Good. Is IH the same thing? Yeah, but technically, when you're putting the lettering in, it should go that way. And that's like the other part. So it's quite literally reading off of the letterings and try to match things up. In the book, I know it looks like a lot. Literally these first 10 problems in this part is just what we just showed him. What I showed out there, where it's like, hey, CD is congruent to what letters? You just match it and going. Right? Go ahead and pull that up on your Chromebooks and whatnot now if you want to take screenshots, take pictures of it to people's phones. That's cool. You got about, you guys have more time to go. About 10 minutes or so. Shouldn't be a big deal. Okay. Don't lose those progression sheets, guys. They become rather important. Which I have one. Do.